Hello everyone. So today we'll be discussing about interview questions which are being asked regarding to operating system. So first one is here, what is an operating system? So if we talk about an operating system, it is a program which is acting as an intermediate between the user and the computer hardware. In order to work properly in a computer system, we need to have a program which is operating system. So user is provided with some kind of interface which is provided to interact with the computer hardware. So that is termed as the operating system. So it is a layer which is, you can say, in between the hardware and the user interaction. So the main task or goal of the operating system is to provide a convenient environment to the user to execute their programs in a convenient and efficient manner. So convenience to the user, that is the first goal of the operating system, and efficiency is another goal of the operating system, to provide the user with a convenient environment or easy to use environment or easy to interact environment with the hardware. So whenever the computer is designed, the main goal is to provide the user with a functionality to work with the computer hardware. So in order to work with the computer hardware, we need some kind of software which allows our interaction to be done in an easy way. So that is the main thing which is being covered by the operating system. So it allows for the user interaction with the computer hardware to be done in a convenient and efficient manner. So that is what is operating system. Then there are some operating system functions which it provides. So we can say that operating system functions are those things which are being provided by the operating system in terms of its features, or you can say its services. So first one is like process management. So process management is something or a feature which is related with the creation of different processes which are being worked out when we interact with the operating system. So suppose I click particular file, I click on a particular option in the system, so that will generate a process in the background. So that process is basically being executed by the CPU, that is the central processing system, and that operating system will control the execution of that process over that CPU. It will perform allocation of memory, it will perform allocation of resources to that process while it is executing over the CPU. So that process management whole scenario is being covered by that operating system. So whenever you perform some operation on a computer system which is provided with a user interface, so we are generating basically the processes, and its management is being governed by your operating system. Means whatever process requires, it is being served by the operating system. So that is a module which is performing the process management. Then we have something which is called as main memory management, or it can be categorized as the memory management component. So main memory management is another important task of operating system, because operating system will work out to manage the main memory or the RAM which is being required to execute your programs over the system. So whenever a computer program is being executed by use of that CPU, central processing unit, the operating system will try to manage that main memory requirement of that program. So that is another feature of the operating system, which is main memory management. Then how we'll describe the next feature, that is file management. File management is basically the thing which is related with the memory management itself, because files are storage mechanisms by which we can store some data. So data is being stored in terms of a file, or information is being stored in terms of a file in the operating system's storage part. So that is how the main memory and this file management are related. So file management is corresponding like how the files will be stored in the computer system's storage and how they will be retrieved, how they will be processed. So that is all management of file is done by use of operating system features. Then we have something which is called as IO system management. IO system is like input output system management. So it is one of the feature in which we are dealing with the input and output devices and managing their operations by use of the features provided by operating system. Like when you connect your keyboard to the system, so operating system will identify that this is the device which is used to perform input operations, and some device drivers are being installed when we plug in that device, or the operating system by default note that this type of device, if it is connected, So this is used for the input purposes. So that is the input device which is being managed by your operating system. So that is one example. Another will be like, suppose you want to provide some output, so you will require some kind of output device which is like monitor or your printers. So those devices are also being managed by the operating system component, which is used to perform the IO system management. So that is another feature. Then we have secondary storage management, which is this one. So secondary storage management and the point which we have discussed into is main memory management. They all are part of the memory management component of the operating system, and that component is termed as your MMU, which is main memory management component or MMU unit. So that is basically supported to provide secondary storage management, means the disk which we are talking about is being managed by operating system. Apart from this, another feature is of networking, which is being provided by operating system. So operating system should allow us to connect with other systems or over a network and make our network connectivity easier. So that is another feature of operating system. Then we have system protection. That means protecting the user from external or internal threats or improper use of that system. That is also being covered by use of this system protection feature of operating system. System protection is like how to protect files, like we can allow passwords, we can allow the user to access a particular account by use of passwords. So all password management or even protecting the users by use of some internal antivirus protection softwares, like we can install firewalls, we can have those Windows Defender kind of thing in case of Windows based system. So we have system protection feature enabled because of the operating system. That is another component. Then we have command interpreter. In earlier generation of operating system, we used to have like disk operating system, which is not having a GUI, graphical user interfaces, absent in case of DOS. So in those systems or operating system, how we perform all these functions by use of some commands. So operating system should able to interpret our commands, which we can give by use of that interface provided in our systems. So currently systems which we are using, or the currently operating system which we are using, they have the support of command interpretation. Like they use command prompt to access the CLI part, that is command line interface part, which is being used by the DOS operating system to provide commands in terms of interaction with the hardware. Like user will use that command line interface and give commands to the system to access that particular hardware or interact with the hardware. So that command interpreter feature is also being supported by the operating system, and it can also be said as the function of operating system. So next is, what are operating system services? Services are just like your functions which are being provided. So we can have program execution, means whenever the process becomes or the programs are being executed by the operating system. So that is one thing. Input operations, whatever input operations that we can control. Then we have file system manipulation. So what is the file system? It is a component of operating system which tells you about how we organize and store and retrieve the files in a particular operating system. Like in case of Windows operating system, we used to have file allocation table, FAT file system, or nowadays we used to have NTFS, new technology file system. So those type of file systems are being used by the operating system to store and retrieve your files in a particular well-organized fashion in a computer storage. Then there is a feature of communication. There are some methods by which we can communicate or perform some communication related operations. So that is another service which is being provided by operating system, like communication between programs or communication between different devices. All is governed by operating system and provided as a service. Then error detection, moreover related with the system protection functionality. So in case of there are some errors while accessing some files, like suppose you have moved some file to a different location, so operating system will tell you that that file is not existing in the current location. And sometimes you will find some errors being detected by your operating system itself, like file not found or 404 errors or all those type of errors. So error detection can also be one of the feature. In case your system is going out of memory and you are trying to access that, that is also error protection or error detection. Then we have resource allocation. So whatever resources, software or hardware which are being supported in a computer system are being allocated to different processes to perform various tasks. Like suppose in case we have a printer installed in the system and there is a multi-user environment in which multiple users are able to access that system at the same time by use of some network connectivity. So that resource can be utilized by n number of users. So it has to queue up all those requests one after the other, and resource need to be allocated in an efficient manner. So that resource is basically our printer, and its allocation should be governed or protected in one way or the other, so that no two users should able to access them at the same time and there is a confusion. Even if they are giving commands to that printer at the same time, it should be queued up one after the other. So that is resource allocation and usage. Then accounting. Accounting says that whatever operations that we perform on the operating system should be accounted with in terms of efficiency and time. So we talk about time and memory efficiency and usage also. So that is accounting for how much duration the resource is being utilized. Like when you open the task manager, so you can able to see the usage of a particular resource or a service. So that is moreover like keeping the account or record of servicing be utilized and for how long and for how much memory requirement they are using it. Everything is covered in accounting. Then we have protection in terms of system protection and resources. Like Windows have a user access control account, UAC. So from that we can create, we have a different administrator account and the user account and the guest account. So that is how the operating system also allows us the protection feature. Plus there are some features which are like firewalls which we can have in the operating system to be installed to prevent threats to be entering in our system or prevent the users from network attacks. So all those internal features which we provide as part of the operating system can give us this feature of protection. Then what are the various different types of operating systems? Next question comes is different types of operating system that can be asked. So we can have batch operating system, we can have multi-programmed operating system, we can have time sharing operating systems, we can have distributed operating systems, we can have the real-time operating systems, we can have multi-processor systems. So all these are various types of operating systems that we can have. We can have even multi-threaded systems. So that can be another category which you can figure out. So let us discuss them one by one. So first one is your batch operating system. The idea of batch operating systems which were designed in the initial years of operating systems development. Batch operating system club multiple jobs which are having similar requirements or similar kind of needs. They will batch them together and run them simultaneously. Before the batch operating system, there is another type of systems which were developed, which we call as serial processing system. In case of serial processing systems, we can have only serial instructions given to the hardware one after the other. I cannot give multiple programs or multiple instructions at the same time, or even I cannot keep multiple instructions in the main memory simultaneously and we can run them one by one. Even that possibility is not there. Serial processing says that user will give a command. Until unless that command is processed, the user cannot give another command. So that is basically serial processing systems. In case of batch operating systems cover the problems which are being figured out in the serial processing system, which says that in serial processing we used to have single instruction or single input given at a particular point of time. Even I cannot keep multiple processes in the memory at the same time. So that is the problem with the case of serial processing. Another problem with serial processing is that it is giving the output after a long interval of time. So time is also a limitation. So until unless first operation is being completed, I cannot give another process to the hardware to execute and give us the result. So that will take too much amount of time of processing. So that is the limitation. In order to overcome the limitation, we use the batch operating systems. So batch operating system is, the idea is to batch together jobs with the similar needs and run them together. So we can group jobs with the similar requirements and run them together. In case of batch operating system, the main memory or the storage is being divided into two parts. One is your operating system and one is for the user program. So it is divided into two parts. One is used to store our operating system, means operating system also resides in the memory, and in the main memory I'm talking about, not talking about secondary storage, because at that time secondary storage was not being utilized in case of batch operating systems were there. And also we used to run the programs over the CPU by this second portion. So CPU will utilize this area to execute your programs by keeping them into the memory. So this is the memory which is being talked about, and memory will hold both operating system and CPU related processes which are being required in the memory. So that is being utilized. And in the operating system part, we used to have something which is called as monitor or operator, which sorts the programs which are fed at the same time into the memory and according to their requirements execute them. So who will perform this batching task or batching together task? There is a component of operating system which is called as operator, which batch together jobs with the similar needs. And monitor is the one which is being controlling all these operations on part of the operating system also. And the problem with this is that it is time consuming but makes the CPU busy all the time, because CPU will have some job to execute, and based on that we can have this batch operating system. Still the problem is that even I can keep multiple processes in the memory at the same time, but I cannot execute them at the same time. So that is the problem which is being put forward by the batch operating system also. And it is also occupying the main memory part by using the main memory area to store the operating system. So it is like wastage of memory. I cannot keep too much instructions, or I cannot utilize the main memory for my processes. So that is another wastage of memory which is being governed by the batch operating system. Then comes the generation of your multi-programmed operating system. In case of multi-program operating system, we can execute number of programs concurrently. So now there is a feature which is being provided in the multi-programmed operating system, which is executing or allow us programs to execute concurrently at the same time. So that is another feature which is being supported by multi-program operating system, not available in the batch operating system. So the tasks which are being performed by operating system in this case, job scheduling. Job is like, suppose I put a particular or I perform a particular operation, so that becomes my job to be performed by the CPU. So that is job, and to schedule that job over the CPU or to give the CPU to that particular job is termed as the job scheduling. Okay. So whenever we perform some operation on the system, that becomes a process. So that process is treated initially as the job, and the requirement of operating system is to perform this job scheduling. What is the meaning of scheduling? Scheduling says that executing or providing the CPU to different jobs which are present in the system at the same time. So that is scheduling. One after the other, CPU should be provided to different jobs. So that scheduling and its criteria is decided by operating system, how we schedule the jobs over the CPU for execution. And the advantage is that it keeps the CPU busy all the time. So CPU has always one job to execute. So one after the other, jobs are being provided to the CPU and we perform job scheduling in an efficient way. So here the feature is that we can concurrently execute the programs one after the other. Even the programs can be stored inside the memory, and operating system now moves out of the main memory. Now the main memory is completely used by the programs or processes, and this is the main memory which I am talking about. So it is being used by the programs or processes. It is not utilized for the operating system storage. So we talked about efficiency of our system, and we talked about memory management also in case of multi-programmed operating system. So multiple programs can be executed or can be stored at least in the storage area, and they can be fed to the CPU one after the other as the CPU works out. Then we have time sharing operating system. Although in case of multi-programming we are saying that concurrently they are executing, but it is not exactly concurrent execution. So in case of time sharing operating system, we can have this feature of it is set as a logical extension to multi-programmed operating system, where the user can interact with the program while it is executing. In case of multi-programmed operating system, we can concurrently execute them, but while executing, I cannot interact with the program. Like suppose you are writing or you are providing some input to this particular program. So when you are providing that input, you can provide it, it will try to execute, but while execution, you cannot interact with that particular program. That is the feature which is not available in case of multi-programmed operating system. So interaction while execution is not supported, but in case of time sharing, we can interact with the program while it is being executed over the system. And CPU also uses a mechanism of sharing the CPU time by switching the jobs and the CPU among them by use of time sharing. So time sharing is basically making the task of concurrent execution feasible. Means we are sharing the CPU time and utilizing that CPU time by use of CPU switches. By use of this mechanism of CPU switches, means I can switch the CPU from one process P1 to another process P2, and that switch is being controlled by our operating system. P1 से P2 में switch कर सकता हूँ CPU को, and that is being controlled by operating system as the different processes demand them. So it is an extension to multi-programming, which is also providing concurrent execution, but the thing is that I can interact with the program while it is being executing, and actual file sharing is being, or the CPU sharing is being performed in such a way that every user is given the impression that it is interacting with that system at a single point of time, and CPU is not being utilized for different processes or different performing different tasks at the same time. So user is given the impression that whatever job is being performed or the application is being executed, they are being executed at the same time, but actually behind the scene it is being shared in terms of time. CPU का time share हो रहा होगा, but ऐसे लग रहा होगा कि every application is being executed at the same time because of CPU switching, which is very fast in case of time sharing systems. Our normal system which we use right now are time sharing with features of multi-threading also supported in those systems. Like operating system that we use today is of time sharing type, which is sharing the time of CPU, and their CPU switches are very fast that we never know that CPU is being shared among different processes at the same time. So that is the idea about your time sharing operating systems. Then we can have real-time systems. Real-time systems are used to deal with the real-time processes, and when we talk about real-time processes, these are those processes which must respond to the events within a certain period of time. So that means in case we have in system some processes which are bounded by the time, so based on that I can categorize those systems as real-time systems or real-time operating system which used to support that kind of interaction. Means those systems which are time bound, or the processes which are being executed over those systems are time bound. Means if the time is over, there is problem with the execution of that operation. So in case of time bound operations, we used to have real-time operating system like live streaming. Live streaming is one of the feature which is required by support of real-time systems. Although our normal operating system used to have this kind of feature which is supported, but in the earlier generation they were categorized in a separate way like real-time systems. Plus in case of robotics or industrial applications, also the real-time systems are being required. Like suppose robot is moving in a particular direction, and a slight delay in that movement will result into some kind of error. Suppose robot is moving in a particular direction in a towards a wall. So if that wall is not known to that robot in that minisecule of time, so robot might bashed up into that wall. So that is the problem in case real-time systems are not that efficient. So if the robot doesn't move either left or right, so he might bash into the wall. So that is the case with the real-time systems, because the time is important. Time period is the important factor in case of real-time systems. So what are different types of real-time systems? There are two types or categories of real-time systems. We have hard real-time systems and soft real-time systems. In hard real-time systems, obviously time is important, but the guarantee is that the critical task will be completed within a given amount of time. So it is moreover like a stricter time-based systems, and soft real-time systems can bear some kind of delays. These are those systems which are also dependent upon time, but if there is a slight delay, there is not an issue with that system. So it requires critical processes receive priority over the less fortunate ones. Means I can provide some kind of delay. Means based on the priority of the task, I can give or schedule that operation, and I can put other tasks to wait for a moment of time. So due to that waiting time, I can say that it is less critical in terms of talking about the time requirement or time foundation of a particular process. So that means in both the cases we can have multiple processes working simultaneously, but in the case of hard real-time systems, we cannot bear any kind of time delays. But in case of soft real-time systems, we can have some kind of time delays which can be bothered or which can be beared by the processes executing. Like in case of industrial applications, suppose you are manufacturing a robot, or we are manufacturing some kind of machine on a conveyor belt, and you are tightening some screws. So that is a hard real-time system. Even if there is a slight delay in the movement of a particular unit which is moving towards the second part of that operation, in which screws are being tightened open on that device. Suppose I am manufacturing a car by use of the robotics assembly line, and that assembly line is moving different parts in a different direction, and in between there are some different locations on which different operations are being performed. Like somewhere the tires are being attached to the car, somewhere there is painting going on, somewhere there is screws tightening going on. So all those things are worked out in a particular time ordered manner. Means if the machine is not at that place at that time, it will not able to perform that operation. So that is hard real-time systems. In soft real-time systems, we can have some sort of delays which is being maintained. There is no issue with a slight delay in the operation. Then we have multiprocessor systems. Multiprocessor systems are ideally executing your processes or more than one processes executing over the CPUs at the same time. So multiprocessor says that we have more than one processor working in close communication with each other. Like we can have CPU 1 and CPU 2. Both processors are actually accessing different processes which are coming into the system and being executing over it. So in case of multiprocessor systems, multiprocessors like multiple CPUs. So these are ideally making the task of concurrent execution possible. In case of time sharing systems, user is given the impression that tasks are executed concurrently, but they are not executed concurrently. They are being executed one after the other, but the CPU switching is very fast that we are not able to identify that switching or that sharing of CPU time. But in case of multiprocessor system, ideally the system is capable of executing two tasks at the same time, ideally. So that is the difference between multiprocessor and time sharing systems. So if we talk about further categories of multiprocessor system, we can have symmetric and asymmetric multiprocessing systems. What is the meaning of symmetric? Symmetric means we are having the similar capacity computers or similar capacity systems which are running the identical copy of the operating system. That means every processor is having an identical copy of the operating system which is being governed by that particular environment. And these copies communicate with each other as and when they are requiring it. So operating system being installed on those systems which are being governed by one CPU or more than one CPU, and we can have multiple operating system even installed in the single environment. So every operating system is supposed governed by one processor, like in case of virtual environments. So in those situations, I can have identical copies of operating system being executed over the multiple processors which are being used to perform your task at the same time. So exact concurrency is being achieved by use of these kind of systems. In case of asymmetric multiprocessing, different processors can have similar or non-similar copies of operating system installed over them, and each processor is assigned a specific task. So in the earlier case, we are used to communicate with each other, and here every processor is assigned a specific task to perform. So as per the load bearing capacity of the processor, a task can be categorized. Suppose a higher processing requirement task is there, so it can be run on a particular type of processor only, which is running a specific type of operating system, so I can assign that task to that processor or that system. And another way, we can have a different way of governing it. Then we have what is the difference between multi-programming and multitasking system, that has been asked many times during your interviews. So multi-programming involves context switching to shift among different processes, and multitasking basically involves time sharing. So context switching is also involved in case of time sharing environments although, but in case of multitasking we are sharing the time along with performing context switching. So it is a logical extension to the multi-programming, or we can say multitasking are actually your time sharing systems. In case of multi-programming, we are not sharing the time of the CPU. In case of multitasking, multiple tasks are being executed actually at the same time by use of the time sharing environment. So that is the difference between them. Plus another difference, as we have discussed in time sharing and multi-programming, like there is user interaction allowed while the program is executing in case of time sharing, which is not allowed in case of multi-programming. So that is the main difference between them. So when someone asks, multi-programming is not ideal execution of concurrent execution, and multitasking is actual multiple tasks are being executed per unit time, and that is the main difference. Then next question that comes to mind is, what is a process, which we are talking about since the start of this particular session. So when we talk about a process, it is basically a program under execution which is termed as a process. Means suppose there is a program, not like programming language based program, it can be any program, any particular piece of software which is combination of multiple program. Suppose I am running that program. When the program is being executed, we say that it is a running process. Okay, so that process is basically the program under execution or program in execution. And when we talk about the processes and their classification, they are generally categorized in two types: operating system processes and the user processes. In case of operating system processes, I can say that we used to have this operating system governed operations like memory management, file management, all those things. And user processes are the tasks which are being governed by the user. So suppose some operations are being run in the background by operating system, like firewall management or background or properties or like display management. All these are operating system processes. And when we talk about user processes, it is all the user commands which are being converted as the or referred as the user processes. So then comes, what are the states of a process? States of the process means while the process is being executing and unless it is terminated, what are the various states or what are the various situations in which the process will undergo. So as the process will start, means whenever you click on something in a computer system, it is in the new state. Then we can have running state, waiting state, ready state, and terminated state. So if we talk about the new state, which is the beginning state of a process, so new state is the one in which the process is fed into the system and it is waiting for getting the memory. Means there is a, you can say, 1 picosecond of time which is between this new and the next state of a process, which is your ready state. So if we talk about the states of a process, first one is new. In a particular sequence, I can say that next is your ready state. Then we have running state. In case, I can say running as RG. In case the process is your waiting for some kind of resource, so it can go into the wait state. Suppose it is waiting for some input-output device for getting its task to be completed. So that will lead to the waiting state. That means it is not running, it is actually performing the wait operation. Then finally it can be terminated. So that can be the fifth state. So this is the order in which the states are being associated with a process. So whenever the process is fed into the system, it is in the new state. When it is waiting for memory to be allocated, so that is the ready state. When the memory is allocated and it is waiting for the CPU, so it will become the running state. Or when the actual program is being executed over the CPU, it is running state. When the process is waiting for some resource, so that is the waiting state. And when the process actually quits, either by itself or by forcefully, So that is the terminated state. So all these are the states of a process. Like new is waiting for memory allocation, or like executing or requiring the memory. Then when the memory is allocated, so process is ready to be executed over the CPU, but it requires the CPU. When the process gets the CPU, it is in the running state. Like suppose while it is executing, it requires a resource which is not being currently available. So the process will go into the waiting state, and finally it is being terminated. So this is basically the life cycle of a process during its execution throughout the system. Then what are the reasons based on which the process can be suspended? Someone can ask you how the process can be suspended. Suspended means like temporarily out of execution. So in case we are performing swapping means suppose we are using different processes in the system, and one process is has to wait for some duration of time, and the memory is being swapped from that process to some other process. Means we have a memory limitation, so we have to execute concurrent processes at a time. So during swapping, like one process moves out of running state and goes into the waiting state, and another process will be in the running state. So that is basically swapping the CPU. And in case of interactive user request, suppose initially the user has requested or started a particular application. After some time, that application is running, but user has started to access some other application. So initial process will be suspended momentarily, like in kind of a time sharing feature. So based on that, we can suspend that. Then we have a timing feature. Suppose we have given every process a limited amount of time to execute over the CPU. So that is moreover like a timing process. So once the time is over, the CPU can be suspended or the process can be suspended. Then the parent process request. Suppose there is a parent process and a child process. What it means is we are starting a program. Out of that program, there is a sub part of that program which is being running. So that can be said as a child. So on the parent process request, the child can be suspended. Okay. So that can be stopped in between. So that is the process suspension. Then we have what is a thread. Because sometimes the question asked by interviewer is what is the difference between process and thread. So thread can be said as a subpart of a process. Like suppose in case of your Word application, you are typing some lines of code or lines of statements. So in those statements, your line count is being maintained, your character count is being maintained, word count is being maintained by the word processor, MS Word processor I'm talking about. So in those situations, we are saying that those subparts are being also executed at the same time. So that is possible because we are creating threads of a process. Means a process is further divided into subparts, and those subparts of a process as a single application is termed as the thread. So it can be said as a lightweight process because it is subpart of that. So it can be having smaller memory requirement, smaller CPU requirement. It will execute for a smaller duration of time. So that can be said as a lightweight process. So it is the basic unit of CPU utilization. What does it mean is when we increase more number of threads in the system, CPU utilization is going to be increased because CPU is concurrently being shifted among different processes, and we have n number of processes available for the CPU to execute and switch between. So when the CPU is busy all the time, we are saying that we are utilizing the CPU that fast enough. Suppose we have only one process with two threads or two subparts. So CPU will switch between only those two subparts. If suppose we have a process with 10 threads, so it will switch between 10 threads. So it has to work very fast in order to switch between each and every thread so that user will not get the delays. Because if the switching is slow, suppose it will go to part 1, then part 2, then part 3, 4, 5, 6, 7, one after the other, giving each of them the CPU time for execution concurrently by time sharing. So in those situations, we can say that the CPU utilization is not proper because the task is slow. If the CPU switches very, very fast among all these 10 subparts of a process, so we can say that the CPU is being utilized to the fullest efficiency. So based on that, this threading will increase the CPU utilization. That's why it is said as it is the basic unit of CPU utilization. Based on this, CPU utilization can be enhanced. So that is all about your thread. So the difference between process and thread is a thread can be the smaller part of a process or a running process. Then what is the thread consisting of? How we identify thread? So different parts of a process can be identified by the thread ID, and then we have every thread associated with a value which is called as program counter and register stack and the stack. So these are the four entities which are associated with every thread in the operating system. So thread ID is for unique identification of that thread, like thread 1, 2, 3, 4. Then we have program counter. Program counter is the variable in which we store the address of the next instruction to be executed when a process switches from one place to another place. Suppose there is a function which is being called in a program. So when that function is being called, the part of the function is being executed, not the calling function which is being executed. Suppose we have a main function. Inside that main function we are calling another function. So when the program is being executed, it is started from the first line. At suppose fifth line we have a function call statement. So that function call will move the control of the CPU to that function code, not the initial code which is being executed. So in between, if we are switching to a different location, so program counter knows the address of the instruction which was being executed prior to that. So once the function call is over, the CPU will continue with the first function and the next statement of that first function will be executed. If we don't maintain that address somewhere, the CPU will, when it moves back to the first function, it will start executing it from the first line itself. So when the switches between different parts of a program are being executed, this program counter is going to help us with the address of previous instruction being stored in that. Then it has a register set. It is used for the temporary memory which is being occupied by the thread for execution or fast execution. Then it has a stack portion which is for local variables which are being required by that thread for the storage purpose. So every thread will have these four things which are being part of the thread for execution.